So in this video, we're looking at binary search trees. We're going to define a binary search tree. We're going to understand the algorithms for inserting and searching for items. And we'll look at the algorithms for deleting as well. And there's a few different cases for the deletion item for us to go through. The definition first, it's a binary tree. So each node can have a maximum of 2 children. However, the left child must be less than or equal to its parents. The right child must be greater than or equal to its parents. And there are no other restrictions on the height or the completeness of the tree. We're going to implement this in object-oriented programming. We would have a node class, and there would be these attributes. So we're going to maintain a pointer to the parent of each node. We'll have the left and the right child as a pointer to the node as well. And then we'll store the data. And here there's an attribute called key, which is just going to be an integer for this case, which is going to be the data to be stored. Here's the insertion algorithm in pseudocode. So we're passing in here, T is just the tree, and new node is an object of that class that we've just seen. X starts at the root, but only if it already exists, and P is going to be a variable that keeps track of the parents of the current node. The while loop checks if the new node is less than or greater than X, and then it changes X appropriately. All the time we're keeping track of the parent as well. Now in this bottom section, this is at the end once we've found the insertion points. If P is equal to null, that means there's actually nothing in the tree, and so we need to create the root node. Otherwise, we're going to create the node to the left of the parents if it's less than it, or to the right of the parents if it's greater than it. So we can walk through it now. So there's some data there, 10, 5, 2, 12, 11. In the first case, we're looking to enter 10. So X will become t.root. Now, there isn't actually a root at the moment, so that's going to resolve to be X is equal to null. We've got P is equal to null, X is equal to null. So in that very first time through, X is equal to null, so that while loop is not going to trigger at all. So we get down to the bottom then. P is equal to null, yes it is. We're going to set the root node to be the new node. So t.root becomes the node containing 10. But next time we're adding 5. So new node contains the key 5. X is t.root, well we've got it this time, so that becomes the node with 10 in it. And while X is not equal to null, we can run the algorithm now. So P is equal to X, P becomes X. If the new node.key is less than X.key, then X equals X.left. So before we actually place the node, X.left is just a null pointer. So X becomes a null pointer here. That then ends the while loop. New node.parent equal to P, which is at the moment is the node containing 10. If P is equal to null, it's not. If the new node.key is less than P.key, which it is, then we set the left pointer of the parents to become new node. So here we've set the left pointer of the node containing 10 to point to the new node that we've created, which is the node containing 5. The parent of that node has already been set to be the node containing 10. And we've got a couple of null pointers at the bottom just pointing off. So entering 2, going to follow the same process, except that it's going to go left after 10 and then left after 5 once more and insert the item there. Inserting 12, it'll start at 10 and then traverse to the right and place the node there. And then for 11, it's going to go right from 10 and then left from 12 and place the node there. And again, I've just added the arrows, the lines at the bottom, just so you can see where the null pointers would be as well. So an activity for you now, on a piece of paper, sketch out the insertion of the following data and just show the tree in how it would be if those items were inserted in that order. Pause the video and I'll model it afterwards so you can see if you've got it right or not. So let's do the walkthrough then. So we start with 15 as the root node. 7, go to 15, traverse left. 23, go to 15, traverse right. With 4, go to 15, traverse left to 7, go to left to 4. And follow this through. And that's it.